Hello dear students, welcome to the lecture 2 of this particular course of semiconductors, and in this particular lecture we are going to see the basic understanding of semiconductor. Basically this deals with the introduction part of the semiconductors, and these are the certain points that I am going to discuss over here. So as you can see over here, the very first point is that foundation of electronics. So let me go to the next page and let me explain a bit about electrical and electronics, because this is the question which an interviewer targets whenever you go to interview in any company, or maybe if any institute. So basically the difference between electrical and electronics is that, see the overall circuitry, like the overall idea behind the working of circuitry is same, but the difference is over here. That is, electrical deals with conductors, while electronics deals with semiconductors. So this is where the difference is, or I would say the basic difference is. So whichever component you take, I hope that you might have heard about diode, PN junction diode, BJTs, FETs and all. Okay, so they deal with the semiconductors. Okay, and basically semiconductor is backbone of electronics, and whatever devices which you have in your home, maybe oven, maybe TV, maybe laptops, maybe mobile phone or smartphones, or maybe any kind of things. Right now all of the things are dealing with electronics. Okay, so as I hope you might have heard the word digital. So basically again this electronics is divided into two parts: analog and digital electronics. Okay, analog electronics and digital electronics is derived from analog electronics. So this is how it is. But forget about this particular thing. You need not to worry about this particular thing. You should just have a clear idea that electronics deals with semiconductor. That means a semiconductor is a backbone of electronics. So I hope you understood this particular part. Now we will move to the very second point. So as you can see over here, so basically we are done with this particular part. So this particular line, as you can see over here, acts as a conductor and as an insulator. That means what? That means it will behave, or it has certain characteristics of conductors as well, and it has some characteristics of insulators as well. So that's what we are going to see in the further course. So basically, as you can see, this is a basic definition of semiconductor. So conductors, okay now? And semi means what? Partial or half. Semi means what? Partial or half. I will write over here half. Okay now? So basically it it will behave as a half conductor. Okay, and partially it will it will behave as a conductor partially, and partially it will behave as an insulator, Okay, so this is what this line tries to specify you. And I know that at this particular point you might get stuck, that how it can behave as a conductor and at the same time as an insulator. No, it won't behave as a conductor and insulator at the same time. It won't behave. Okay, at the same time it won't behave as a conductor and an insulator. You have to alter certain parameter. Okay, you have to alter certain parameter, and based on that parameter, so let's suppose that parameter is P, and based on this particular parameter, you can behave it as or basically that semiconductor will behave as a conductor, or it will behave as a semiconductor. So I hope you understood about this particular line. You understood what exactly this line tries to tell you. I also know that you might have not got the clear-cut idea about this particular line, but as a layman's term, this is the definition for semiconductor. That is it partially behaves as a conductor and partially it behaves as an insulator. So I hope you understood a basic idea. I'm not telling that you should understand in depth as of now, because this particular line has in-depth concept which we will be learning further. Okay, so you need not to worry about this particular line over here. Okay now? So yeah, we are also done with this particular line. And now moving further, used to control conductivity. So see over here, this particular line is related with this particular line. How? As I told over here, that we have to alter certain parameter, and based on this parameter we will basically the semiconductor will be behaved as a conductor, or it will be behaved as as a semiconductor, okay, or basically as an insulator, not semiconductor, as an insulator, okay now, and this as a conductor. So that parameter is nothing but the conductivity. So basically conductivity is opposite of resistivity, as we all know, and basically resistor is nothing but rho L by A, which we had learned in the course 1, okay na? And here the resistivity means this particular resistivity, and this is the conductivity. This is conductivity and this is resistivity, okay. So by altering the parameter of the conductivity, what we are doing, we are actually changing the characteristic of semiconductor. So we are for certain amount of time we are actually behaving it as a conductor, and for certain amount of time we are behaving it as an insulator, okay. It solely depends on what application we are using it for, okay. So I hope up till here it is crystal clear, okay. So the conductivity is the technical term over here, and we had dealt with it in course 1, okay. So even if you had not idea about the conductivity, I hope now you had got the clear cut idea, because it is showing a clear cut relation between, the inverse relation between the resistivity. So this is your resistivity. Let me write it over resistivity, and this is your conductivity. This is your conductivity, okay. So as your resistivity increases, your conductivity decreases, and vice versa, okay. So I hope you understood this particular concept or this particular line. And now this is very much important. Let me erase these things first, okay na? Let me erase these things. Yeah, this particular line is pretty important. Only allows unidirectional flow. That means what? See. In basically in lecture 1, in course 1, what we had done is that, if let's suppose if this is your conductor, maybe any wire, okay, any wire or conductor I'm writing as of now. Let's suppose this is the positive terminal of the battery and this is the negative terminal of battery, and I had applied certain amount of voltage over here, and due to which current I will flow in this particular direction, okay, for some time. Now what I had did, again I am taking the second conductor of same length and area, okay. We are not dealing with in that depth or about the conductor, but now what I am doing, I am altering the voltage, altering the side of the voltage, see, and I am applying the same voltage, plus V over here and minus V over there. So now the current will move in this particular direction, and it will come over here. Similarly, it will go and it will move in this particular direction. So basically the current is moving in this particular direction over here, and for this particular circuitry the current is moving in this particular direction, okay. But now what this particular line tries to specify is that, let's suppose in place of conductor, if I implemented or if I just attach the semiconductor over here, okay, semiconductor, and if I apply let's suppose a voltage, certain amount of voltage, let's suppose this is that voltage, plus minus V, okay, and if the current is moving through this particular semiconductor, let's suppose current I is moving through this particular semiconductor, so that current will, so this current will only move in this particular direction. That means what? Even if you, let's suppose again, if I'm drawing this particular semiconductor, okay, and let's suppose this is that voltage I'm applying, but in the reverse fashion over here. So this is the negative and this is the positive terminal of that particular voltage. So in this scenario, and this is that semiconductor, okay. So in this scenario the current won't move, okay, the current will not move, or the current won't move in this particular direction, okay. So the voltage drop across this semiconductor, you will get here as 0 volt, while in this scenario you will get plus minus V volt over here. That means what? It is showing that the current is flowing from that particular semiconductor. So from this particular phenomena, what we can say is that current is not flowing in this particular direction, it is only unidirectional. So that's why over here I had highlighted one term, unidirectional. That means semiconductor will only allow the flow of current in one direction, either in this direction or either in this direction. It solely depends on the application and obviously the semiconductors that you are using. Okay, so I hope you understood this particular point. Let me just tick it over here that we had done with this particular line. Okay, now see over here, this is the basic idea about like before semiconductors, what all things that we were using, okay, for our daily purpose. So before semiconductor we were using vacuum tubes, but the thing was that it was costly, okay, and again it was consuming more power it was consuming. Then it was using high energy. Basically energy and power are almost same, almost. Okay, if you want idea about power and energy, I discussed in the course one. Okay, so yeah, before semiconductors vacuum tubes were used and they were consuming high power and energy. Okay, then the maintenance cost was more. They were maintenance cost were more. Then they were consuming more space. So space consumed by the vacuum tubes, it was more. While in contrary, if we see the advantages over the vacuum tube of the semiconductor, so you can see it consumes less energy. So we are done with this point. There is nothing to explain this particular point. It is just idea, or basically, sorry, not idea. It is just an information regarding what we were using before semiconductor or before the introduction of semiconductor in field of science and physics. Okay, so we were using. If anyone asked you, or if you want to know about vacuum tubes, there is L amount of information on the internet, so you can go through it. Okay, so yeah, we were using vacuum tubes before the introduction of semiconductors. So now we are going to see the advantages of semiconductors over vacuum tubes, or basically in general we are going to look upon the advantages. So as you can see over here, the first advantage is that it consumes very less energy. Okay, it consumes very less energy. Then it is long life. It lasts for very long time. You can see your mobile, like if you can guess that, sorry, meant to say that just before 4 to 5 years back, the smartphones like Micromax and Lava and maybe all those low budget smartphones, they used their life was around one year maybe. But now the phones life has increased maybe 2-3 years, and obviously the life of the battery also has also increased. Okay, so this is because the internal structure, basically internal semiconductor of the phone, because the phone has semiconductor, and as I can say, as I had explained to you over here, that the semiconductor consumes very less energy. Okay, so since the semiconductor consumes very less energy, so obviously the battery life would be more. Okay, not only the battery life, but the semiconductor life is also more. Okay, and the most important thing, it consumes very less space. Okay, so for example, in like a vacuum tube, let's suppose this is that particular area. Okay, and a vacuum tube consumes all of this particular area. Okay, but in the same area 100 to 200 semiconductors, that means diodes, triodes, whatever transistor would be implemented in this particular area. So this is what this particular line tries to tell you. They are small in size, and that's why they consumes very less space. Consumes very less space. So I hope you understood this particular part. So this was all about the introduction of semiconductor. So let me revise the things again, so that like you will be very much well acquainted with this particular topic, and it will help further to learn the things in much more detailed way. So as you can see, foundation of electronics, as we had discussed over here, the basic difference between electrical and the electronics. Okay, and generally the interviewer target this particular question in interviews. So yeah, this is what I wanted to tell you. Then the second thing is that acts as a conductor and an insulator. So basically this is the definition. So this is the definition of the semiconductor, like by altering the certain parameter. And that parameter is nothing but the conductivity. We'll try to see it. We'll try to see this particular phenomena in great depth after some time. Okay, right now I'm not at all revealing all of the things, so that if I reveal these things now, then you will be getting very much confused. Okay, so the parameter was the conductivity. Okay, and we also saw that the semiconductor only allows the current to flow in one direction. That means unidirectional current to flow. Okay, it only allows unidirectional current to flow, that we had seen from this particular diagram. Okay, then yeah, it was just a small information. Before introduction to semiconductor, we were using vacuum tubes. Okay, and advantages of semiconductors over vacuum tubes were, actually there are n number of advantages, but as of now, as a layman, you should only understand the three important advantages. That is, it consumes very less energy. Okay, it is long life. Okay, and it is small in size. Okay, and there are a number of advantages which we will be probably we will be seeing or we will be discussing in future. Okay, so I hope you understood each and everything up till here. Thanks for listening me very patiently. I'm ending this video over here, and we will meet in next lecture with some new topic. Thank you.